Hello again. In the last video we created the base pickup class, and while we set up some replication and network scaffolding, a lot of the things that we did were fairly abstract. So in this video we're going to actually create the derived battery pickup, and then we're going to add some art, set up the physics to work over the network, and actually see some things happening in the editor. So let's go ahead and get started. I'm going to switch back over to my editor right now, and we're going to first create this battery pickup class. So we have our base class. We just right click on that and say create C++ class derived from that. So we're going to call this the battery pickup. And then that is, as usual, the editor is going to create the class, compile the code, and then flip us over to Visual Studio so that we can start editing the code. Now again, we're going to end up with a very basic class setup with fairly bare bones, nothing in there, but that's okay. All we really need in this case is to set up our constructor so that we can set the default values for instances of this class. So that's our battery pickup. Okay, now that we have actually declared it, let's go and define it. And I'm going to do that little shortcut, Control period, and then create that definition. Oh, but it failed. It doesn't like me. Figures. That's okay. So let's go over here and do it manually, the old-fashioned way. A battery pickup. Okay, now just like in Epic's tutorial, we need to ensure that physics works on this object. And the way we do that is to get the static mesh component and tell it to set simulate physics to true. So we're going to do that. So get static mesh component and set simulated physics to true. Now, the other thing that we have to do in order for this to work over the network is we need to make sure that it is understood that this is a movable object. And we do that by also doing that on the static mesh component. So we get the static mesh component, and in this case, well, the way we do that is to say, is to call a function to set its mobility. So we set mobility, and the type of mobility is movable. So E component mobility movable. And once we do those two things, that will tell the engine that basically this pickup is physics enabled and should move. Now we don't do that in the base class because, or the parent pickup class, because not all pickups may need physics. Not all pickups may need to move. So that would not be very useful because it would be excessive work for nothing. So we're going to ignore that. Now if we went to compile this and actually went into the editor and tried this out, it would work, but what we would see is a problem, which is the object would move, the battery would move if you bumped into it, but the movement would not be the same on both client and the server. The reason is because we're simulating physics, so it's being simulated on the client and the server independently. So in order for those to be synced up, we have to tell the engine that we want to keep that movement synced up between the server and the clients. So we have to do that. Let's keep movement synced from server to clients. And the way we do that is by setting our B replicate movement to true. Once we do these three steps, we'll basically be able to have a working battery that's going to bounce around and do all the things we want it to do over the network in the editor. Now we can go ahead and compile, and then we'll flip back over to the editor to get this actually implemented, and then we'll add the art. And then we'll pretty much be done with this video. So let's go ahead and, while that's compiling, we'll flip back over to the editor. And here we have our battery pickup. We're going to actually create a blueprint class for this so that we can make edits to that blueprint class. So what we need to do now is create a new folder. Just right click, create a new folder. I call it blueprints. And then we'll take our battery pickup and create a blueprint class from that. And what I like to do is preface blueprints with BP underscore BP_battery. We'll put it in the blueprints folder. Click create. And now we're opening up into the blueprint editor. So what we want to do here is make adjustments to settings and things that we set in the class as defaults, but it's easier and it makes us get faster iterations on testing if we can edit the values of things in the blueprint. So while we're doing everything in C++, we're not slavishly connected to C++, we're actually going to do things in an intelligent way as well. So now we have the battery here, we can start setting up the other components so we can add the art. But in order to do that, we need to get the art. And where are we going to get that? Well, if you did the other tutorial, you know from Epics that what we do is we go get the content examples project, which I'm just going to drag that over. I've already got that open in the editor. So get the content examples project, and we're going to find two things. We're going to get the battery. We'll get the SM battery medium, and we're going to migrate that over into our project. So we right-click on it and go Asset Actions, Migrate. We're going to migrate this entire set. Click OK, and we need to find the folder. This is the NMP game project, the content folder. Click on the content folder, say OK, and the editor will migrate everything necessary for that asset. Now the other one we need is the electricity, which is this electricity arc. That's going to provide us the electric arc later on. Same thing, Asset Actions, Migrate. Migrate the whole set. Same thing down to our project content directory. OK. And there we go. That's all done. So we are finished with that. I'm going to get rid of that. Flip back over here. And now you'll see that here we are in the project, and we now have some stuff here with this new particle effects loaded up in our editor. So we can go back in our blueprint, and what we need to do is actually set that static mesh to that battery. So there is none right now. Let's just click that drop down and search for battery, SM battery medium. Perfect. So now we can compile and save, and just like in the other project, in the Epics version of this, if we actually spawned an instance of this battery, it would work with physics in that it would start falling, but it would fall right through the world. The reason is because the battery does not, by default, have collision. So we need to double click on that, open up the static mesh here, and you notice that there's no collision represented here. So we need to add that. And we'll add 18 DOP simplified collision. That will give us some nice contours so that it'll roll around and fall over and stuff when it hits the ground. Save that. We're all done there. We can close that. And now we've got the battery set up as the object. And we have everything we need right now for us to go in here and click. Let's drag in an instance of this battery, drop it in the level so we can see it. And we'll click play. And there we see on both the client and the server, it's sitting right there in front of us. I'm going to bump into it. Bump, send it tumbling over, and then I will switch over here to the server, run over to check it out, and lo and behold, it's in the exact same spot from both our perspectives. And I'll kick it back over to the client. I'm going to kick it way over there. Still sitting there, looks pretty good. I'm going to check from the client again, and sure enough, there it is. Okay, so we have the object set up. We have the asset, and we have the physics and everything happening. It's being simulated, the physics is being simulated, and the movement's being replicated, so it moves the same in both. So that's good. That's all we needed for this video. In the next video, we're going to set up the spawn volume that will actually spawn these objects and drop them into the level for us. Okay, we'll see you then.